In this Godot Multiplayer tutorial, I'll teach you how you can spawn players into the map so that the players can see each other. Let's get started. Before we can start spawning in players, we need to make sure that our scenes are ready. We need to make sure that the map has a container that can receive these players, and we need a sort of a player template that we can spawn in for every other player which is not the player itself. So let's get started with the map. I'm right here on the map scene where I have my tile maps. I got my Y sword, my trees, my player, and the enemies, which in this case would be the mobs, the NPCs. And under this Y sword, I'll add another child node that will be a Y sword, and I'll conveniently rename this Y sword into other players. So we have a place to spawn them, and they'll be Y sorted with the rest of the assets. Now we need to make sure we got a player template, so let's move on to that. Now for the player template, we can make use of the player scene that we already got. Both players can do pretty much exactly the same, else we wouldn't have an equal game. So we need exactly the same node structure, or almost. We need to make a couple of slight changes. The first thing I'll do is I'll duplicate the player scene, so I have two separate scenes both for other players and the player itself. So we'll duplicate the scene, we'll call this scene player template, and we'll have it right here. Make sure you open it and that you adjust only the player template scene, not the player scene, else you're going to be in for some surprises. Under the player template scene, we need to make a couple of adjustments. First of all, we don't need a camera on other players. We don't need a camera on ourselves. So we're going to be deleting the camera node out of the player template scene. Now, we also want to recognize these different players, at least while we're testing it. We can't have yet, or we won't program yet, that we see a visual representation of the equipment the other player will wear. We'll need a lot more data for that, but let's at least make sure that we can differentiate between one and the other. So I'm going to select the head sprite. This is a stacked sprite sheet, and you can see here I have the head, I'll have the offhand, I'll have the main hand, and I'll have the armor. So for the head sprite, I'll go to the visibility stats right here, and under modulate, I'll give this a little bit of a red color. So our other players that will spawn in will have a red head. Now, with that done, we currently have the player script still connected to this player template as we copied it from the player scene. But a lot of this code is not necessary for the spawned in players. In fact, if we were to leave this here, we'll see both players move at the same time when we're moving our own character, which is the last thing we want. So under the player here, I'm going to be removing the script with the delete script button right there, and at the same time I'll rename this. Oh, if it wants to cooperate, I'll rename this to player template so I have more indications whenever I'm working in which scene, because these scenes are going to look so familiar to each other. We got to make sure that we're working in the right scene. Right, we got to do another couple of things. Right here we have the layers for the collision, and of course these are copied from the player, but we want the player and the other players to be able to bump into each other, so we need to make sure that they can see each other. So this player doesn't have to see anybody, because we're not going to be programming any movement on the other players. Those will be moved by the other players behind their clients, and then the server will tell us where they are. We're not going to move them ourselves. So we don't need any masks on this player. We don't need it to be in the NPC layer either, because basically that's what the server will decide, who is attacking where and colliding where. We only need to make sure that our player can see that player so that they can bump into each other. So with that said, camera removed, layers adjusted, the head adjusted, the script gone, the scene renamed, and of course we can also add a script here. We're not going to do much with that yet in this tutorial, but have a place to start storing some code in the next couple of tutorials that are coming up. So with that done, we have a player template. Now I guess we're ready to spawn in some players. Now, the only place to know when we have to spawn a player is of course the game server, when another player is actually making a connection to the server. So I'm right here on the game server in the network architecture, and I'm on the main game server script, which is the interface with the player. Right here we have, well, when a pair disconnects to start with, we are pretty sure we have to despawn a player at that point. And also when we have the verification results that we're sending off to the player, we can also say that, well, okay, if we have a positive verification result on the token level, which is the last step in logging in, then we're pretty sure that we need to spawn a new player. For now, we don't have a player location yet, as we don't have any world state or player state from the other players yet. So for now, I've hard-coded in this vector, which we'll replace in a future tutorial with a player position that actually comes from the server. So that's for later. For now, hard-coded. So that means that we're gonna have two functions, the spawn new player and the despawn player, which needs to be programmed on the interface on the other side, on the client. So switching to the client, we now have two new functions. We have the spawn new player and the despawn new player. The spawn new player receives the player ID and the spawn location, and the despawn player also receives that player ID. That player ID is not the ID of actually this client. That is the player ID of the player that actually logged in, because we got that player ID from the return verification results, which would be for any player logging in. So that's an important thing there. These two connections are made to the map scene. So we are pushing these functions forward to the map scene because the map has to be spawning them in. So that's a logical place to put the code. So going back to the actual map scene right here, I've added a new script on the top, and this is pretty much all I'm doing currently, because this is of course still a very simplistic game, only to demonstrate these multiplayer functions to you. I'm preloading on the top that player template scene that we've just made. Then I have the function spawn new player and the function despawn player. For the new spawn player, we're first gonna check if the received player ID is equal to the peer ID of this player, because of course this function is also going to be firing when the player that's actually logging in, that's going to get that function as well. And we don't want two players of the same player, because then we would have like a sort of, we will be ghosting ourselves, I guess, sort of. So whenever the player ID of the player that's logging in is the same as this client's pair ID, then we know we have to pass. We have to let it go. We don't have to do anything, because that's ourselves logging in. In any other circumstances that's not equal, it means that it's another player logging in. We create a new instance of the player spawn. We set the position to the spawn position, which is now that hard-coded vector 2. We rename the node, so that will be actually that player template right there, that name on the top. We rename that into the player ID. By renaming that into the player ID, it will be very easy to reference this particular node in the future when we have to update the position of this player whenever we get a new world state from the game server. What a world state is, we'll get into in a moment. Then we're going to get the node YSort other players, that player container or other player container we create at the start of this tutorial, and we add the child. Pretty easy. When we despawn a player, we get the player ID again of the player that has been disconnected. And then we are simply going to get the node YSort other players. We find that particular player representation, that template, and we query it. And that's pretty much all there's to it. Now, of course, you will be wise to ask for a demonstration, so let's do that. The game server, the authentication server, and the gateway server are already running in the background, so I'm just going to hit press on this client and log in with this player account that I've created for this demo. I'll drag this window over here. Then I'll go down and open up another Godot instance. I'll open up another client, and with this client, I'll hit play as well. We'll make that smaller, we'll make that smaller, and now you can see whether the player is gonna be logging in there. Of course, I have to make use of a different user, and I'll log in. Now, as you can see, we have an issue, because right here we got the second player with the red hat spawning in, and we can walk around here and well, have fun, and we'll bump into this player because we set those collision layers. But right here we don't actually have that second player. The person with the, well, let's say brown hat is of course the player itself now. They're not in exactly the same location, because I've changed the spawn location right here hard-coded, so that's why their location is not in sync. That's expected. But the problem is we don't see the other player. So that's the elephant in the room. Let's address that. Right now, this player is already logged in, and it's listening for any other player logging in. But the moment we actually make a login, we also have to retrieve all the players that have already logged in before us, that are already populating the game world. And we're not doing that right now. In order for us to do that, we'll need the world state. We need a list of all the players with their positions and all the other stuff. And that's pretty much where we already get into how are we going to build this world state, which is probably the next tutorial. So right now, we're not going to do that in this tutorial, but it is why you see these differences, and it indicates what we're going to be doing in the future. We have similar issues because when we kill this werebear here, this werebear on the other player doesn't die, and this player can kill it as well. That's because that werebear is governed by the client. Its HP is on the client, position is on the client, everything is on the client. And that's of course not what we want. That werebear is supposed to be living somewhere on the game server, so that when one player kills it, the world state is updated and other players can see it die as well. So I've mentioned world state a couple of times, I've mentioned future tutorials a couple of times, so I think it's a good moment to explain to you how we are going to get those world states, what exactly we're going to do, and what you can expect in the next couple of tutorials. And then you'll probably understand why I don't do it all now right here, because things are going to get, well, complex, because this is multiplayer. You didn't expect it was going to be easy, right? So with that said, let's have a look at that diagram. Right, so this is pretty much the situation we're in. I've taken out the authentication server and the gateway from the network architecture diagram, because once we have a connection with the game server, that's pretty much the two entities we're dealing with. So to start off this world state and syncing of location of players, we're going to start with the client. They'll have an outbound signal that is going to be communicating the player state to the server. We're going to sync that with the physics process engine, so it's going to be sent out about 60 times per second. On top of that, we'll do a local execution of the movement code so that the player has a smooth feeling of a smooth response as soon as he presses any buttons or moves his player character. So with those outbound signals, the game server is going to be receiving these signals. It's going to be receiving all the player states, plural, because of course we're going to have multiple clients connecting to one game server. It's going to be receiving those signals 60 times per second minus any possible packet loss. And we're going to be saving that into a collection. The reason why we save it into a collection is because we're going to process it as these states come in. It could be that the client 1 is sending it on one particular millisecond, and then the next client is going to be sending it 1 millisecond later, because the physics process engines of all the clients are not synchronized. Now these signals are going to come in random at any millisecond, and if you have 100 players connected to that game server, the game server is going to be receiving signals pretty much every single millisecond. So if we were to process all of those signals as we go, then the game server pretty much has to do things every single millisecond instead of 60 times per second. So that's 1,000 times per second instead of 60. And 60 is even way too much. It's not necessary. So we're going to be doing 20 times per second. And because we do it 20 times per second, we're accounting for possible packet loss. Like I stated here, there's chances there's packet loss. So basically the client has 3 chances to get a packet through, which is more than enough. Like packet loss tends to max out at about 2% in normal circumstances. If it gets much more than that, then there's definitely something wrong with the connection. So there's more than enough time to collect the states of the player. If the player sends a state while there's already a state, an unprocessed state in the collection, and he'll just override that. And whenever we are processing the collection 20 times per second, we'll just take the most recent states we have received from all the players and we'll start generating a new world state. So with that said, we are going to be processing states in the collection into a world state, and we'll also retain a history of a number of world states so that we can go back in time for lag compensation. And that's a more complex topic that we'll do at the end of this series probably. So with that done, now we can have an outbound signal from the game server that is going to be communicating the world or chunk states. That's an option here. If you got a big game, you of course don't want to send to every single player every single other player's position, because maybe some other players are kilometers away, and that packet, this world state, is of course going to be much bigger than the packet that is outbound here. Right, here's a couple of variables: player position, player rotation, and maybe some other things, but not much. when you have the outbound signal here going back to the client, this is going to be the rotation and position of every single other player, every single mob, maybe even every resource node which has been mined or not, and maybe some other things that, you know, we have to make sure that that's all communicated. So we're going to have the outbound signal that's going to go to the player, and that player is going to buffer it. And that is really important, because you may have been wondering, well, if we do this 20 times per second, isn't it going to get laggy? Well, yes, if we wouldn't compensate for that. So we're going to be saving these states in a buffer. So at least the current state and the next state, and we might even do the previous state as well if that is necessary. We'll figure that out as we go. Now with that buffer, what we're going to do is we're going to render everything which happens in the world state with 100 milliseconds in the past, basically. So the client will always see whatever happened 100 milliseconds in the past. We'll make sure through this method that there's an as high as possible chance that there's always a future state in the buffer for the client to interpolate between. Now that's a lot of difficult words, so let me explain it a little bit. Basically what we're going to do is that the client is going to process these world states, and it's going to look, okay, let's say the last packet arrived 100 milliseconds back, and I have a packet that's maybe 20 milliseconds in the future, just to say something, to say some numbers. That means that whatever happened, or whatever I have to display now, is between 100 milliseconds in the past and 20 milliseconds in the future. And because it has both these states, it can interpolate in between. It can basically tween in between these two states, and therefore still display smooth motion, even though we're only sending these signals 20 times per second. So if, of course, we for some reason don't have a world state, we can also extrapolate. We can take the velocity and the rotation of every single entity, and we can say, okay, we don't know where it's going to be in the future, but based on history, we know its direction, we know its velocity, so we can predict, best guess, that it's going to be there. Now, if that happens, which we hopefully can reduce with this buffer, but if it happens, of course, there's going to be small deviations from reality. A player may have turned during those couple of milliseconds, or a mob may have stopped and started attacking. So what we'll do, we'll update the world, and if we have any extrapolation which resulted into deviations, we're going to rubber band it. You probably played MMOs a couple of times, or other games, that you suddenly see a mob just sort of being dragged over the terrain, and suddenly it's somewhere very different from where it used to be. Some games use teleportation, then that mob is just suddenly there, but more and more modern games use rubber banding, because then you can sort of see what's going on and you're not completely surprised. You're just, okay, there was lag. Well, that's pretty much what rubber banding is. So we're going to rubber band any deviations that are a result of the extrapolation, which hopefully we can avoid by interpolating between various states in the buffer, because we're rendering a situation in the past. That's like in one full sentence, that's it. So that means that the player is going to have, because of this local execution, it means that the player is basically playing in a world that is 100 milliseconds in the past. That also means, especially if you're making a shooter, that when you do that headshot, the head may not actually be there anymore, because you're looking at where the head was 100 milliseconds ago. And that is why we're retaining the history of an X number of world states, so that when the player shoots, we know exactly when the player shoots. When we send that to the game server can look back in the past with these various world states, and we can see if that head was indeed in the scope of the player when the player was looking at it in the past, and then we can still award that player the headshot if indeed it was a hit. So all that is what we'll be doing in this tutorial series. But that is, of course, just a little bit too much to put into a single tutorial right after spawning in some players. So we're going to take this step by step, and in the next tutorial we're already going to go full circle and make sure that we can see the two players move around in the world. It will probably be still very choppy, very laggy, but that is where we're going to introduce those various elements both on the client and on the game server. Step by step we'll build it up until we got the smooth motion that we're looking for. Hey, and you may be going like, hey, I heard a couple of other things. You can also send input, and how's this with cheating? Is this safe? Well, those are all good questions. So I would say right now the player can cheat. Because the player, for example, could say on the client, hey, I can walk twice as fast. It's just sending its new position in the player state. And if we don't check for that in the game server, then yeah, the player would suddenly be moving twice as fast. So on the processing of the collection into the world state, that is where we would be implementing anti-cheats. Maybe verify that based on the amount of time that has passed between two states or between two inbound player states, we can check like, hey, your movement speed is 300, but you've moved 600 pixels. That's not possible, so you must have been doing some really funky stuff for that to happen, and we're gonna ban you, kick you, disconnect you, whatever. It is also possible to send the actual input that the player makes. I press W, I press S or A or D or arrows, or I clicked here, I clicked there. The problem with that is that you're still going to be running into an issue with packet loss. Because basically, if one player has a lot more packet loss than the other player, that means that less states are gonna come through with the command I press W. And let's say you're in a chase area where one player is chasing the other player. Basically, it would mean that one player might run a little bit slower because he's losing more packets, and that means that input commands are being lost on the internet and they're not being processed by the game server. And of course, that sort of means that if you want to play competitive, well, if you live closer to the nearest data center where we store our game server, you're going to have a more competitive play, which of course just that wouldn't make any sense, or that wouldn't be fair. At least that wouldn't create any competitive, inviting competitive play. So that's a couple of like what if, or can we do it otherwise. It's a couple of probably answers to some of the comments you may have in the comment section. Keep them coming. Now let me take a quick moment to thank all of you that have become a member of the Game Development Center channel. It is absolutely amazing to see how many people are willing to support the creation of all these tutorials. If you haven't checked out the memberships yet, or if you're just curious what it is, it's sort of like a Patreon, but right here on YouTube, so you don't have to go to any other websites. You can check it down below if you click that join button. That's pretty much it today for this tutorial. I hope you're as excited as I am to see other players walking around and moving around each other in the next tutorial. I sure am. So make sure you check that one out. Make sure you're subscribed, and until next time, keep on gaming, keep on coding. See you later, guys.